Okay, I guess we can get started. So hi everybody, welcome. My name is Nick Berg and I'm the Director of Enterprise Analytics at Seagate. And today I'm going to be talking to you about driving analytics innovation through the enterprise. First of all, I'd like to tell you a little bit about Seagate. So you may know Seagate as a hard drive manufacturer. We operate at about $11 billion of annual revenue, have about 45,000 employees based in 26 countries. And we were the first and only hard drive manufacturer to ship over 2 billion drives around the world, which represents about 1 zettabyte of data. Seagate stores over 40% of the world's data on our hard drives and other devices. And we're a technology leader with over 9,000 patents. But we also do many other things. Just to name a few, we have a branded division called LaCie, where we sell external, extreme design, high-performance hard drives. We also sell solid-state drives, where we deliver amongst the fastest and largest and densest storage technologies in the world. And then we also sell storage systems, including all flash storage systems and hybrid storage arrays. And we have over 800,000 of those systems installed around the world. So I'm going to take you through these analytical foundations and sort of give you this foundational recipe about analytics, and then we'll talk about some added enablers a little bit later. So first of all, let's start off with our data. So where is your data going to reside? It's going to reside in, maybe you have a data warehouse, you may have a variety of data marts, perhaps you've got started on a Hadoop implementation with some data lakes, you may have some streaming data from IoT, Internet of Things. Whether that's in the cloud or on-premise, that's where your data lives, and typically a lot of analysts will supplement that with some externally sourced data too. But if we focus on the core enterprise data, this is where you have to have some very mature data governance and also robust data quality, and with your data pipelines as well, where you want to deliver new data into those corporate data sources and make sure those are very robust themselves. They should be monitored all the time. Make sure they don't break, and if they do break, have some good alerting and automation set up, ideally doing some self-diagnosing and self-correcting. So a simple example of that is you expect some data to be sent in from a source every day. It didn't turn up, so you could get an alert, but also have some kind of automation to correct that problem. As I mentioned, if you have a Hadoop implementation, normally that's done on an evolving basis. So maybe that's another source for you. And then you'll have a number of new projects, innovation projects, where you're developing some new data pipelines too, back into your corporate data assets. Very often, analysts and data scientists are going to be working with data where they want to prepare that data in a variety of different ways. And perhaps they're using a data preparation tool like Alteryx, or in the new Tableau that we're going to get in 10.5 with the data prep capabilities. But what's a really good idea is to set up a sandbox for them so that you can kind of control what they do a little bit without, this is sort of about data governance. We don't want to be too controlling, but what you don't want to have happen is lots of island data sets spread around the company. You really would like to have those incorporated back into your main corporate data assets. So a good way to achieve that is you provide them with a data sandbox maybe on a database somewhere, perhaps your data warehouse. But then what you do is you set up automated expirations so that they can work with that data maybe for a month or two, and then if it goes longer than that, you need to work with them to put it back into fold it back into the main corporate data warehouse or something like that. So having this automated expiration is kind of a good idea because that facilitates that process. Then with all this data, it needs to be easy to access, easy to find, so you need to have a very good data cataloging solution as well. I'm trying to use this pointer here. I'm not very good with this. Data cataloging solution. And then we talked about data quality management and data lifecycle processes and policies. That's deleting the old data. So you're not going to want to keep all the data forever. So you need to have some good policies around that and automation to delete the old data out of these corporate data assets. So moving on from there, I want to talk to you about data virtualization. I'm not sure if many of you know what data virtualization is. So I'm going to very quickly explain this to you, although this could take the entire presentation in itself. But I think it's a very good, very useful tool to complement your major corporate data assets. And so what it is, it's a platform that allows you to connect any type of data into it. So over time, what you can do is you can connect all your corporate data assets into the data virtualization platform. It understands how to connect to any type of data, whether it's a database, whether it's flat files, whether it's streaming data, whether it's in the cloud, no matter what. And then what you do with this is as you connect your data into there, let's just take your data warehouse as an example, you'll need to connect the tables together like you normally would do. So you do that by creating business views, which is essentially represents your data model by joining together your fact tables and your dimensions or other tables you may have in the database. As you do that, the system is recording what all that data is. So it reads the data dictionaries of the database, records all the metadata available, the column names, the table names. As you create these business views, you can add further descriptions and calculations. Why would you do that? Well, what you're doing here is you're creating a unified metadata layer for your entire corporation. And the advantage of doing that is now you can take any of your analytics tools and just point them to the data virtualization platform, and you don't recreate that metadata time and time again. So, for example, in our company, we use business objects, we build business objects universes, we build the metadata there. And then we use Tableau, of course, and then we build the metadata there too, and so on and so forth. So we're duplicating that many, many times. The objective of the data virtualization platform, amongst many other things, is you get this unified metadata layer where you define that once. You may have to define a couple of extra things in your reporting tool, in Tableau, to calculate things on the fly, but the bulk of your metadata resides in the data virtualization platform. So this really helps drive data awareness, because now as you add all your corporate data assets into this platform, it has a search engine in there. You can search for data. It's very easy to find. It's all there available for people. And you don't have to go and set up a database account. In some companies like mine, this could take some time, all right? You just need to get an account on the data virtualization platform and then just apply to use any one of these business views. And typically, these can be very self-service. Analysts can build these business views. Typically, what an IT department will do is expose the data in some standard business views and then allow the business analysts and data scientists to go and create their own derived business views as well, and then add some metadata around that to describe them. So, as I said, it's a very complementary thing. A few other advantages: it can speed up data integration processes. So if you're doing a traditional data warehouse where, let's say you've got a new data set and you want to go and talk to your business users about that data set, how they're going to use it, what are their reporting requirements, what dashboards they want to build, and then the next step is you build your data model, or you update your enterprise data model. And then you'll go and build your ETL, and then you'll push the data into the database, and then finally, after several weeks, you may be able to get some data that you can play with in Tableau. Well, the advantage here is, A, you can speed that process up, because the ETL developers can get access to the data just like any user really quickly. They can start to look at that, manipulate it, they can actually mold it into the final state, and it can really help accelerate that ETL development process. But an even better benefit is that you can start prototyping analytics in let's say, Tableau from day one. I mean, it's very easy to connect the data in, and then you can build this business view, which is really easy drag-drop type of situation, and then you can be prototyping those analytics while your data warehouse team is developing the actual permanent data. Another major advantage of data virtualization is it doesn't store any data. It's all passed through to the system. So that means that you can connect your analytics there actually to the data virtualization platform, and then that will connect to the data source, and this is done in real time. So if you have a real-time need, there's another great advantage of data virtualization. It also has a lot of smarts in it. So it understands databases, it understands explain plans, so it's going to optimize your queries. So if you're querying from multiple sources, which is another great attribute of the data virtualization platform, is you can join any corporate asset to any others, and many of them, is that it'll take a look at what you're trying to do here. And let's say you've got one database over here you're putting from a table that's got tens of millions of rows, and you want to join it to another database over here that maybe has 10,000 rows. Well, one way of joining those is to just pull the data and join them at the end, but that's very inefficient. So what the data virtualization platform will do is say, well, that's only 10,000 rows. Let me grab that data. I'm going to push it down into this bigger table, where the bigger table resides over here, join it down there, and then just return the results. That's much more efficient. So it's got a lot of smarts built in there. It can help increase query performance as well, because it has some intelligent caching. So for example, if you're pulling data from a remote source over a slow network pipe, you can cache that data and so speed up that process. So very scalable. As I said, all the work's been done down in the sources. It's using a pass-through technology, and it's very secure. It understands row security, column security, cell security, role security, and it can even anonymize the data on the fly as you pull it. So very powerful solution. I'd recommend you take a look at it. Moving on from there, let's talk about data acquisition and preparing the data. So as you connect to whatever database or perhaps a data virtualization platform, what are you going to do? You want to search that data and write some queries. So you may be using some data dictionaries and data catalogs to help facilitate that, and perhaps you're searching for a particular product, and then generally these search tools will lead you into a query. Or maybe you're using a custom-based query UI that your company's built to just fit a very specific business model. Or you just may be using a SQL editor with a SQL generator, or perhaps a natural language query generator. Whatever you're using, you grab the data, and then typically you're going to want to prepare that data. So if you're at the keynote this morning, you would have seen that the new Tableau data prep tool has data profiling in it. That's really, really a strong capability that you want to have in any data preparation tool. So what data profiling does is it gives you a taste for what the data is. You can explore that data. So it tells you perhaps some base statistics about the data. What's the minimum value, the maximum value of a particular column? What's the average? What's the standard deviation? How many nulls are in that? How many zeros? And then as you saw this morning in the keynotes, you probably noticed those data profile Paretos, where you can parade it by various categories, by products and whatever else. And that really gives you a good feel for the data as you're working with it. And then you're going to mold this data using this data prep tool into an analytical data set. So typically that's done on a very iterative basis. Maybe it's using some kind of workflow, as in the new Tableau tool and Alteryx, or perhaps it's just creating a script like in a tool like Trifactor. You basically do this on a very iterative basis where you may transform the data a little bit, and then you may do a join, and then do a merge, and whatever else. So as you go along creating this analytical data set, don't forget to enrich it, enhance it with extra dimensionality by joining in some other tables to make it more useful. Maybe you create some derivatives of some type, perhaps a pivot or a roll-up or an aggregate. And as you do that, don't forget the metadata. Don't forget to describe what this data set represents, what's its objective, and any calculations you create. So what we just talked about was self-service data preparation over here on the left-hand side, which I'm trying to point to, but I guess it's not working too well. Okay, so self-created data sets. So as I talked about before, if this is going to have any kind of lifetime and you want to share it out with a bunch of users, so if it's just short-term and you have no reason to sort of integrate it with your data warehouse, then maybe it's fine as it stands alone. But typically, you want to find a home for it. So to do that, you'll probably want to put it back into your data warehouse or into some data mart or data lake, whether it's in the cloud or on-premise. And as you do that, you're going to have to work with your IT team typically, and they may have to remold that data a little bit so it conforms to your enterprise data model. And then if you created some additional metadata, then you'll probably want to get that integrated back into the corporate metadata. And then on the right-hand side here, okay, it's working now, the project-based created data sets. So what I mean by that is that's typically done by your IT team. So you have some new data you want to put in your data warehouse. So you go through that process I talked about before, where they're maintaining the enterprise data model. They're also using enhanced data integration tools. So self-service preparation tools are usually pretty powerful, but really robust ones, tools like Informatica, which is a very mature data loading tool, can do very complex transformations, potentially over and above a self-service preparation tool, and also can load very large volumes of data. So that's typically what your IT team will use. And then they'll be going through the same process of enhancing that data with metadata and dimensionality and derivatives. So as those two types of data sets are prepared, you'll want to go to build your pipeline automation. So what that means is as you get new data in, You have to set up a schedule and set up some monitoring and some alerting and some automation to make sure that continues to flow. You want to share this data set out, so you'll be collaborating with various people in different ways to tell people about the data. Maybe do that through some web portal or through your data cataloging system. But as you publish these data sets, make sure you really explain what that data set is used for, catalog it well, and as we talked about, have good quality and data governance as you go forward. So moving on to the analytics now. So you've probably heard about the 3 types of analytics many times before. So you have descriptive analytics, predictive analytics, and prescriptive analytics. So talking about descriptive analytics first, this is all about history. This is what happened an hour ago. This is what happened a day ago, last week, last year. It's all historical. People call it looking in your rear view mirror. So you're looking back in time. You're doing things like trend analysis. But in terms of the tooling that you use for this, as we discussed before, you're probably going to need a Tableau reporting tool just to output Tableau reports and maybe do dumps to Excel and things like that. You're going to want some kind of charting. Perhaps that's in the Tableau reporting tool, or maybe it's in something like Tableau, which you can also develop your dashboards. And then for what-if models, which can be very useful to allow people to tweak some parameters and see what may happen in the future. You can, again, do that in Tableau or some other tool. But all of these tools need to be modern-based tools. They shouldn't require a lot of training to use. They should be very intuitive, have really great UIs. And the newer tools now have this evolving AI. So it's trying to be a little bit intelligent. So a good example in Tableau, it will tell you some suggestions on how to format a particular data set. Or some other tools can actually tell you some interesting facts about the data as it sort of delves in and looks at it. So these are all very useful things. So these tools should be completely self-service, have a lot of collaboration features around them, where you can discuss dashboards, add comments, and other things. And then, of course, storyboarding is a really important thing. So no matter what type of dashboard or report or whatever it is, you should always tell a story around that analytics so people understand what it's used for. And if you're trying to point out a particular trend or issue in the business, you can storyboard that through. And then as you've created these analytics, you'll typically want to save it somewhere, usually on a server. So there are 3 types of workspaces that these tools should really provide. One would be private, which is just this is my report, my dashboard. I've customized it for my own use. I don't need to share it with anybody. So I want it just stored and available just for me. Or you'll have team-based workspaces where you want to share it with a team, but maybe it's confidential data, so you can't share it with the whole company. So you need to add some security on that. Or in some cases, you do want to share it with the whole company, so that becomes like a public workspace. Some additional features and processes that these tools should support is thresholds and alerting, really key. So you can set up a threshold or business rule to say, if this happens, that's good, or if that happens, it's bad. Alert me via sending an email. As you create these things, you should be adding in tabs in your reports or dashboards to explain where is the data coming from, any assumptions in some of your calculations, and really explaining the why you've put this together, this analytic, what its purpose is. Analytics themselves need to have retention policies. So you don't want people wading through hundreds of reports, which are half of them are dead and not being used anymore. Same with dashboards. So you need to have a good retention policy. This is usually more manual, where people go and delete old dashboards and old reports out of the system. And so you just have relevant information there for people to browse through. So moving on to predictive and prescriptive modeling. These are very closely related. Usually you're using some advanced analytical engines like the SAS Advanced Analytics Engine, or maybe R, or perhaps you have your data scientists writing some Python programs and other things. So this is where it's more for the advanced users, like power users and data scientists. They're using heavy statistics very often, doing some kind of statistical modeling. They're maybe creating some machine learning models. But machine learning is not really artificial intelligence. A lot of people put that together, and I think I did in the later slide. But they're created by humans. They have business rules. But they can be sometimes black boxes where, with neural nets, for example, no one can really explain how a neural net works. So that's a bit of a black box. So what's really important with these predictive models, prescriptive models, is you get them validated, right? Get them validated by a subject matter expert who understands the data, understands the business process, and don't just leave it open for assumptions. So this is still a fairly immature area, so use it with caution, lots and lots of challenges involved. And when you have completed the model and you validate it, these tend to be pretty short-lived actually, but you may publish it out, but don't just leave it there. Keep it monitored, because very often some new data comes along that you hadn't built into your assumptions in the model, and now it's fallen out of specification and it's telling you the wrong thing. So make sure you set up some monitoring on that, and it'll have to be tweaked occasionally. And again, storyboarding. I mean, these in particular need to be explained. And I would go as far as saying that you shouldn't just leave it for people to read through the text, your explainers, but you should probably, for a model like this, you should probably explain it in person and answer some questions about it. And don't just dump out a bunch of numbers that the predictive models come up with, but chart it or put it into Tableau to really describe the model well. So that's your foundational recipe for all the analytic foundations you need within your company. I'm going to go through a few extra sort of enablers. So one is executive sponsorship. So as you launch a new analytics project or a new data set, whatever you're doing, try to get some executive to sponsor that, be able to explain to people why we're doing this, why it's important, why you should use it. That really helps drive adoption. And all of these enablers are really about driving adoption. Evangelists. So very often you'll find Tableau evangelists, you'll find people around the company who really enjoy using the tools and working with the data. So really encourage that and ask them to go out and evangelize to other people to, again, help drive adoption, talk to like-minded people, and form communities as well. So typically sort of two types of communities. For the data scientists, they're talking about machine learning and statistics and other things. So they form a community around that so they can get together, they can share methodologies and best practices, but then also do it with your general descriptive analytics as well. Form a community around those, have meetings, do show and tells, share best practices, and share challenges. Those can be very useful. Collaborate all the time. If you have an analytics group or within IT or otherwise, get some of those people to evangelize too. Very often when you're approaching these new projects, you're going to be working with a business team and they're going to be describing to you their business processes. And invariably, I find this almost happens all the time, is as you dig down into the detail, you're actually going to revise that business process. You're going to find something to improve or modify. So this tends to be very cyclical, because as you put a solution into production, business requirements change all the time, so you come back to that team, and then you may update that business process again. We talked about analytics, data governance. Just automate the heck out of everything with the few resources you have, try and automate it. And as I said, this is all about driving adoption. So I'm going to move on to explaining to you the tools that we use in Seagate. And this forms what we call our reference architecture for analytics. But it's also going to be a diagram that explains to you kind of our forward-looking strategy as well. So I'm going to try and step through this with you using this kind of pointer device. So over here on the left-hand side, we have our data sources. Let's see if I can get this to work. Okay, it's not working quite as I expected. So these data sources, what are testers? Well, in Seagate, we are a manufacturing company, and for example, when we're assembling a disk drive through our production lines, which are highly automated with a lot of robotics, we are testing that drive through every step of that production process. And as we test that drive, we collect a bunch of data. This is actually our big data challenge in Seagate. So that's one of our primary data sources is our testers. Then we have an ERP system, Oracle ERP. We pull data from a bunch of relational databases. We have web services, both internal and external, we pull data from. we, in our Hadoop systems, mainly put a whole bunch of unstructured files in there. That could be documents, that could be text files, it could be images. We do a lot of images, in fact. And then finally, another category of source is our cloud-based data from things like Salesforce.com that we use, ServiceNow, Workday, and we also have the Google suite of applications as well. So all of these are our data sources. Moving on from there, we're going to be using some kind of data integration capability. So OCC is a custom solution of ours. It's, I think it stands for Operational Command and Control, a very IT-named application. What it does is it pre-stages data, a lot of data for Informatica to consume. So Informatica is our main ETL tool, and then we use Irwin for building our data model. And as we go through this diagram, you'll notice there's some blanks here because that's going to be some of the forward-looking things we'll move on to in a second. So from data integration, we move into our data warehouse. So we have our EDW here sitting on a Linux compute array using Seagate storage systems. And then we have our Hadoop cluster over here that runs various compute engines like Hive for querying, Spark. We also have a Microsoft R cluster. And these together are comparable systems which form, as Gartner calls, a logical data warehouse. And we have started an evolving data lake. The way we partition our data in Hadoop is we partition it into tiers. You can see on the right-hand side here, tier 0 to tier 3. And I'm going to start at tier 1. Tier 1 is our raw data. In Hadoop, it's always a good idea to store the raw data first. Some people refer to this as a landing zone. Then what we do is we structure most of that data into a structured tier. That's our second tier. And then we may derive some data from that into the tier 3. And as data will age, then we will archive data. So we archive data onto some slightly different mix of Hadoop machines, which are more storage heavy and less compute heavy. They're still attached into Hadoop so that we can query that data, although a bit more slowly. And if we want to do some really big crunching on that, we'll pull that into the main cluster. So moving on from there, we also have some Hadoop clusters in our factories, doing some local factory controls and other things. And then we have a whole bunch of processes we use against this data, which is specific to the logical data warehouse. We talked about these data scratch pads. So these fall under what I call automation, because typically users are using the scratch pads and they're scheduling data to be moved into that on a regular basis, or we have these explorations built on them and some automation around that. Then moving on to data exploration and curation. So we use Alteryx for data prep right now. We're looking forward to using Tableau as well when that comes in 10.5. And then data cataloging, we have our own custom solution. It's called the Enterprise Data Dictionary, which has a definition of all our common data elements, what the names are and their definitions and descriptions. And then we catalog some of our analytics reports and dashboards. And then we also have a data science workbench where they use various tools for predictive and prescriptive modeling, various different tool sets, and they do some machining, and I guess I put AI in there, which maybe I shouldn't, but leading into AI maybe one day. And then moving on from there, what do you do with all this data and processes where you want to create some kind of results? So these are our analytics tools that we use within Seagate. As I mentioned before, for enterprise reporting or Tableau reporting, we use SAP Business Objects. For dashboarding or interactive visualizations, Tableau. We have a bunch of analytic custom apps as well for custom things within Seagate. Mobile apps, primarily Tableau. And then again, a bunch of advanced analytics platforms and tools like SAS, R, Python, and R Shiny is a visualization tool for R. So that represents our current landscape. So that's our reference architecture. Now I'm going to pull you through what we're working on now and also looking towards the future of what we would like to implement. So starting back with our sources, so Internet of Things, IoT. So we've been doing sort of some of that in our factories for a while, but in terms of streaming data and sensor data, one thing we've been working on, many people do this too as a sort of a first step with IoT, is predictive maintenance. So predicting when a machine is going to fail is a great way to sort of pull that sensor data in, run some analytics against that, and see if you can predict it and shut it down before it fails. So we've been doing some of that. Of course, if you're using IoT, Internet of Things, you're going to want to have some kind of streaming technology. So we'll need to put something in place there. Perhaps we'll point some of our data integration tools at that. Maybe we stream it directly into something like Hadoop. And the other types of technologies I didn't point out is mostly doing batch processing or batch messaging, which aren't using streaming data. Then we're also using another data integration tool called Delboomi. This is a cloud-based tool. We use it mainly to pull data from Salesforce, but we're also starting to use it for other things too, as a complementary tool to Informatica. And then moving on from here, we have actually set up a second instance of our EDW, which we've named EDW-HA for EDW High Availability. Actually, the main EDW is highly available too, so we couldn't come up with a very catchy name, but why did we create a separate instance? The reason is we wanted to put some of our EDW, which is pretty big, under SOX controls, and we didn't want to put the whole data warehouse under SOX controls. So we decided to create a second instance that's really very transparent to the users, where we put our financial data in there and some other data that needs to be under SOX control. So we call that EDW-HA. And then we have our Denodo, a data virtualization platform. So Denodo is the tool that we use. We acquired recently to build up data virtualization, connecting all of our corporate data assets together, building up a unified metadata layer here, which all of our analytics tools can connect to. So as I said, don't define your metadata 3, 4, 5, 10 times in all these different tools, but just point it to Denodo instead. That's going to be a major enabler for us and very productive as well. So that's something else we're working on. And everything that we're working on or is new, you'll see these little clock symbols next to. Okay, so moving on from there, a few extra processes we'd like to implement. So we really want to get to a position where data as a service, where it's so easy to get to data. You can see everything through a single pane of glass. You just point, click, and go. That's kind of where we want to get to. And we want to also continue our automation. I call that sort of data robotics and automata. In terms of data exploration and curation tools, we don't really have any data discovery and data exploration tools. As I said, some of the data prep tools can do profiling, which helps. Maybe this is one tool, maybe it's two, but we are looking for something that can just, as you work with a new data set, maybe a big data set, let me really kind of explore that really well before I go and create my analytics, so I can just really understand what that data is about. Moving on from there, we're going to have some additional things sitting into our big data space, some additional compute engines. Cassandra is another type of clustering technology, big data technology for very large volumes of transactional data at a very high level of reliability. So we're looking to implement a system around that. You may have heard this referred to as NoSQL systems. We also want to introduce some search capabilities we don't have currently on our Hadoop cluster with Solr. We want to put in some GPU accelerators. And we're also using now Microsoft Azure. Our data scientists use that to spin up their own clusters or spin up perhaps a data science workstation or a GPU acceleration machine, use it for a short while, and then spin it back down again. So most of this that you see here is on-premise stuff, but we're moving into sort of a hybrid cloud situation as we bring more capabilities on board. And then we talked about IoT, so you're going to want to set up some kind of edge compute capability. Very often this uses a Raspberry Pi type of system to capture that streaming data and do something with it, and we'll talk about that a little bit later as well. And then finally, some additional analytics tools to generate results. Tableau doesn't really provide real-time dashboard capabilities. If you need something streamed in up to the second, Tableau can't do that currently. So that's a gap in our portfolio. And then finally, similarly with big data visualizations, today, not really a good solution for that. Maybe Hyper will help. But if you want to visualize really large data sets of terabytes in size, we don't have a solution there. So that's our forward-looking strategy in terms of wanting to fill out some of the gaps. Let's move on from here. So let's talk a little bit about Tableau itself. Just a few things to point out as we've had to integrate this into our analytics environment. So Tableau 10 and databases still work best for a live database connection. This is prior to Hyper. If the databases are small or they're on a very fast machine or maybe lightly loaded machine or dedicated. So I would say about 95% plus of all of our dashboards, which we have many hundreds on our Tableau servers, are using TDEs because we just can't find, we can get the kind of fast responsiveness, sub-second query speed attaching to a database. So maybe you've had better luck, but for us, we don't point Tableau directly to many databases. We build an extract through a TDE in the main. And then I think as was mentioned today, you should publish your data sets up on the server so people can collaborate and don't reinvent the wheel and republish that. Also, the metadata can be shared through that method too, or you could use the Data Virtualization platform to do that too, or both. Very large data sets still a challenge, whether you're connecting directly to a database or not. So seeing that keynote this morning looked really good, and I think that's going to be a really exciting enabler. Hadoop can attach to big data systems. In my experience, I haven't found this that useful. If you're talking about big data, our big data system has over 1 petabyte worth of data in it. You point Tableau to that, and you can't really do much with it. So today, sort of simple Impala from Cloudera implementations may work, where you can get sort of sub-second query speed from a Hadoop machine, but most are just too slow. But there are some advances coming out with some specialized OLAP tools and other things where you can get pretty rapid queries. But in most cases, we haven't found pointing Tableau to big data systems that useful. You've probably learned this time and again, but if you're going to do some really heavy lifting in terms of calculations or queries and joins, then don't do that live in Tableau. Try to push that down back into the databases, let them do the hard work, maybe create an aggregate, resurface that back up into the database for Tableau to consume for good performance. I'm really happy to see finally, after many years of asking, that Tableau now has thresholds and alerting set up. These are really, really key. Again, you don't want people to be looking at dashboards and trying to figure out what's important, but if you can set up some business rules to say, go look at this, this is good, this is bad, or whatever. This has been a bit slow progress, and they're not done yet, so they've got a lot further to go, but they're really great capability. We have pretty large Tableau installations in Seagate. We actually have 2 big installations of Tableau clusters, one in our US data center, one in our Singapore data center, to try and give low latency to both sides of the world. And they're pretty complex to manage. Again, every time there's a new release of Tableau, there are some improvements for IT to manage those, but it is still fairly challenging. Okay, so let's move on to next. Just touching on big data real quickly, just a couple of things here. So as I mentioned before, build your data lake iteratively. Don't try to build a big data project. That's why a lot of people fail, because they just try to throw everything in there. Do it on a use case by use case basis, and then you'll get better success. A lot of discussions about schemas and schemaless. We found typically that we schema most of our data, so we push that data from the raw data tier that I showed you before into a structured data tier. So most of our big data is structured, but there are some good use cases for schemaless data where you don't structure that data. You just you structure it on the fly, or create a schema on the fly as you query it. So there are a few use cases for it, but in the main we found that you have to structure it. Can be very resource intensive, developing a big data system, but it's very rewarding too, especially for your IT folks, but other people, to get experience with big data technologies. So a lot of work, but very rewarding. Your data scientists are going to be coming to you about your big data systems, because they're going to be working with data and wanting to calculate things and work with big data sets. And so putting on a predictive model onto a Hadoop cluster where you can parallelize the processing for that gives you a huge advantage in terms of performance. So your data scientists are going to be working jointly at the hip with you on your big data projects as well. Some people talk about Hadoop and big data technologies to say data warehousing is dead. It's not dead. They're complementary technologies. Some examples of why you can't really do data warehousing inside Hadoop is we run on our data warehouse using Oracle several 100,000 queries a day on our data warehouse. You really can't have that level of concurrency on a Hadoop cluster unless you have many, many Hadoop clusters. You're not going to reach that level of concurrency. Also, we run a ton of queries that run in a few seconds to maybe a few hundredths of a second on our data warehouse. But they're small queries. Again, it's a big data system for Hadoop, so you're not going to get that kind of response from Hadoop. You're not really going to want to run the small queries on Hadoop. You're going to want to run the really big ones. So you still need your data warehouse. And then cloud compute and GPUs, just really exciting advances for big data technology. Okay, just a few more sort of tips for success with analytics. So we talked a lot about tooling here, but really the main focus should be on the business needs, not the technology. So always focus on what is it the business actually need, and then go and figure out what the best tool for that job would be, not the other way around. We talked a lot about maximizing adoption. That's really important when you make an investment with Tableau or anything else. You want to continue to drive adoption. So make sure your tools that you're using are highly self-service, easy to use, and have great UIs. A little bit repetitive there, but important points. Coordinate your purchases of tools. So make sure that sales aren't buying one tool and finance buying another tool, and they have a complete overlap. And now you have to support both of those. So coordinate these purchases. Make sure you figure out how to balance your portfolio, like I showed you with our reference architecture. We always look when we have a new need. Can we use something else for that, or do we have to buy it? And then actively retire older systems. Also resist building something from scratch. If you can buy it or buy pieces of it, do that first, but resist building it yourself. Different categories of users. So I categorize sort of two ends of the spectrum. One end is the low-touch users. These are the busy people who really don't have time to mess around with it all. They just want to get to the data, get to the answer, and they're out of there. And then you have the other end of the spectrum where you have your high-touch users. These tend to be your data scientists and your power users and your analysts. So once you address both ends of these spectrums of users, really the rest come for free because you've accommodated both ends of the spectrum there. We talked about governance. One quick mention about data governance councils. We have a data governance council in Seagate, and what we do with it is we have a representative from each business unit in the company. We meet about once a month. But what we do is we talk about kind of big data issues. I'll give an example. So we needed to change our product part numbering to a different method and a different type of part number. That touched almost every area within our company, across the company. A big, big deal. And then it impacted hundreds of systems. So the Data Governance Council were the ones that decided on what the new structure of that part number should be. And then they worked through the project of making sure that every single organization adapted their systems and their business processes around that. So very, very important to try and have a data governance council, not just for projects like that, but for resolving problems. So people can't agree on how you calculate cost. So have the finance people and the sales people and the supply chain people and whoever else come in and discuss it in the data governance council and come up with the correct definition. And then finally, in terms of driving adoption, attending to education is really important. We have a full-time trainer on our staff, and we do provide all types of training. But what's really useful is creating content as well around your tools, around your data, and creating quick how-tos about how to do something. So Tableau has some great free training, so we don't do a lot around that, but we still offer classes about how to get started with Tableau development, how to use the server in certain ways where we're a bit more customized, or creating some video snippets about how to do something specific, like maybe how to publish on our servers. So bringing this all together, what analytics is all about is it's all about business value. That's what you need to think about at the end of the day. But it's also about adaptability, flexibility, and speed. So if you can address those 4 things or 3 things, then you're going to be very successful. Foster an analytics community. I've talked about that in many different ways, having evangelists, having data governance councils, having analytic communities around data science and around predictive and prescriptive analytics, as well as descriptive analytics. Review your analytics strategy regularly. Come up with something like we've done with a reference architecture, and discuss this with your executives, with your business teams, gather all their input, and especially align to the corporate initiatives as you work these projects and these new toolings that you may do. Of course, having great people helps as well. If you have a team that specializes on analytics, then try to identify some people as engagement specialists. And what I mean by this is it's someone who can go out to the business teams as they have a business problem they're trying to solve with analytics. That specialist can go in, they can discuss the different types of toolings, provide some suggestions on methodologies, and even help design the solutions. So a very sort of business-centric, sort of user-facing person to go in. We have a few of those who specialize just in that, working with the business teams. Try and be as agile as possible. So in any of our data projects or our analytics projects, whether we're just doing data or whether we're doing both data and analytics, we try to be very agile. So we use agile methodologies. We use things called sprints. We divide a project up that may be 3 months long, and we deliver it in 4 or 6 week sprints. So you're delivering value very quickly right away. Business users love that. We talked about tooling, but avoid tooling sprawl. What I mean by that is duplication, disconnected solutions that don't talk to each other. That doesn't really help. And if you're building custom solutions, then always attend to your technical debt, which refers to things like a developer may just do a quick fix here, or he needs to get something out quickly, and so they just put something in temporarily. Well, that's technical debt. It's going to break one day, so go back and make sure you address that and get that sorted out and coded properly. Kill any underutilized solutions. You don't have many resources, but at the end of the day, just make sure you have lots and lots of fun. Okay, that's all the material I've prepared, so I'd like to just open up for any questions. Yes?
So you mentioned, I guess, Tableau wasn't the center of your architecture overall, and I saw a couple reasons why it wasn't. I mean, the large data sets was an issue. Real-time data, I think you mentioned, was an issue.
All right.
I saw a point about tabular reporting isn't great with Tableau either. We're trying to roll out Tableau ourselves. We're trying to understand, we're trying to make Tableau at the core and then have all the data sources kind of build connectors for all the other data and kind of have everything there, but it seems like that's maybe not the right approach for us long term. Maybe you can talk a little bit about that.
Yeah. I would say, Tableau has certainly been very, very successful in our company. It's definitely sort of very viral because it's great to use, it's great to work with. So I'd say that is the centerpiece of our analytics tools, I would say. But then you need to have other tools surrounding it. So you just touched on some. So there is a place for tabular reporting, all right? So if you need a report, a sales report sent every day to someone, then and they just want to look at the top sales, there's no real dashboards or interaction in there, then you could use Tableau to do that, but as you start to look at more and more of those use cases, you'll quickly find that you'll probably need some kind of tabular reporting tool. We talked about using big data, so Tableau I don't think really works very well with big data, so you may need a different solution there. Real-time dashboards is another one. So I think it's maybe the 80-20 rule, perhaps. You probably could do maybe 80% with Tableau fine, but you'll find these more specialized use cases where some other tools may need to work. And in fact, with us, I'd say it's not quite 80-20 really, because our tabular reporting business objects, it's fairly mature, but whenever we do an analytics project, it's usually a mixture of some dashboards and a few reports as well. So it really just depends on your business. Yeah?
Can you talk a little bit about organizational structure? How what you have shown is very impressive.
Right.
How from your experience, should an organization be structured to achieve something like this?
Yeah, that's a good question. Obviously, it varies from company to company. I can just describe how we're organized, and we actually sort of gone from different models as well. But I guess where we started off was, because this is going back maybe 10 years ago, so we focused more on the technologies. And so we were structured by, we had a bunch of people who worked with reports and dashboards, and people who worked with the data, ETL developers. We didn't find that very effective. So we're now organized more in terms of business structure. So we have teams that work in sales and finance, and they become more specialized in that, and other teams that work in manufacturing. We find that much more effective, where ETL developers, the DBAs, the dashboard developers all can work together. But nowadays, because all these tools are self-service, what I find is that we do very little report development and dashboard development. We just enable the business teams to do that. So in some cases, we'll do that, and we provide some consulting. If it's a big project, we may, just to kick it off, create a dashboard or two or a few reports, and then we hand it to the end users, the business teams. We don't ever own anything ourselves. So we find that very effective. So we focus more on the business requirements and the data side of things, preparing the data for them, corporate data assets. So how we're organized, we have a team in Asia because we have a big user base in Asia where most of our factories are. We have a team in the US. And as I said, we're more organized around business functions. Yeah.
Talk a little bit more about self-service analytics. So do your end users actually go out to your data virtualization platform and grab the data from there, or is it already living in Tableau server for them? What are some of the different possibilities?
Well, it's really all the above. So we do publish data sets on the Tableau server. Data virtualization is pretty new for us, so we're still in the process of implementing that. That's why I put it in with a little clock symbol. But what we're hoping is that will be sort of the single pane of glass eventually, where people will just go in there, they'll do a search, find the data attached to a business view, and away they go. So right now it's mainly our data warehouse, so that's very mature. People know how to attach to that and get data from there, or they'll just go directly to whatever the source is that they need. So we're hoping to push them mostly into the data virtualization platform as we go forward, and of course whatever is published on the server is really the first step. So it's a combination of all the above. Yeah.
So how are you dealing with, you mentioned before that for especially data that you're trying to pull out of Hadoop, that you're not doing that live, you're using extracts. So I assume you're building those in Alteryx or in Informatica and pushing them there. How's that going to integrate with what you're doing with Data?
So you're talking about Hadoop specifically?
Yeah.
So
we're at that point where we're
yeah.
doing the same thing.
So with Hadoop specifically, what we're typically doing when we use Tableau is, as I said, you can't really point Tableau to a massive data set. So you're going to have to aggregate that. So what we'll do is we'll aggregate that, and then we typically will actually put that back into our warehouse, because all of our tools are attached to the warehouse already, including Tableau. Users know how to use that. So if you wanted to pull some big data and consolidate it down into something that's something that Tableau today can consume, maybe with Hyper this will change, we'll typically aggregate that up and push it back into our data warehouse for our users to use. Does that answer your question?
Yeah. But what about the TDEs? Are you using Alteryx and Informatica to build those and push them? And if you're doing that from Hadoop, how are you dealing with the size and the
Right.
publish issues?
Right. So again, attaching Tableau to big data system, you have to shrink it down to something usable that Tableau could use. Mostly aggregating it, yeah, and we use Alteryx to do that too, yeah, and develop the TDE. Yeah. Other questions? Yeah.
Follow-up, so if your users directly have access to the data warehouse and they just directly query it and pull it,
Normally what we do is we ask users to use Tableau, where we have the published data sets or some existing dashboards. And similarly with business objects where we have universes. So we don't typically allow users to attach directly to the data warehouse, but if they have a specific need, then yes. We do have many hundreds of people who have access directly to the data warehouse. This will change a little bit in the data virtualization platform because you can put a lot of safeguards in there. The reason we don't want users to access the data warehouse directly is because you have to write SQL for that typically. And you can write bad SQL and then affect all the users' performance with that. So we try to push them to other solutions. But with the data virtualization platform, there's a lot of controls that you can form around that. So we'll be much more open in the future for people to attach to that. But again, look at the Tableau server first, or look at the existing universal reports. If you don't find what you need there, go to the data virtualization platform, search the catalog, and then you can get onto a business view very easily there. Okay. All right, any other questions? We've got time for a little bit more. Okay, well, thank you. If anyone has any further questions, I'll be outside. But thank you very much, everybody.